All right, welcome to Lesson 7, the definition of derivative. Okay, let's talk about what's going to be happening here. What we're going to be doing is we're going to be taking the limit as h goes to 0 of the secant lines. So let's look at this. So here's x, here's y, and here's our function. Okay, so here's our secant line. So here is C, and here's a secant line from C, and here's a secant line, and here's a secant line, and here's a secant line. And as this H gets closer and closer to C, so this is a secant line, this is a secant line, this is a secant line. But as we get closer and closer to C, it becomes a tangent line, and so this becomes the slope of this tangent line. Not the tangent line itself, but the slope. Okay? And that's what we're going to be finding, is the slope of that tangent line. The definition of the derivative, so how we find the derivative, is actually given here. And this is the general form. And this is what we'll be working with. I don't actually like putting in a constant, but I like finding it using the derivative, because once you find the definition, then it doesn't matter what constants you put in. Now, the other thing that I like to do is I'm going to show you how to use Pascal's triangle. And the reason I like to do Pascal's triangle is I don't want to have to FOIL out a whole bunch of times. Okay? So let's do Pascal's triangle. If I have a plus b, and Pascal's triangle is a method for finding coefficients. So finding coefficients of a plus b to the n. So if I have a plus b to the 0, that's just 1. If I have a plus b to the first power, that's just 1 and 1. 1 and 1. If I have a plus b squared, then we know that that is a squared plus 2ab plus b squared. And so our coefficients are 1, 2, 1. And the way we get the 2 is there. If we add the 1 and 1, we get 2. So what if I have a plus b cubed? Then I get 1, I add these 2, I get 3, I add these 2, I get 3, and then I get 1. So let's notice that if I have a plus b, then what I get is I get a cubed plus 3, a's go down and b's go up, plus 3, a's go down, b's go up, plus b cubed. So if it's raised to the 4th, it's a plus b to the 4th, so that's 1, 4, 6, 4, 1. A plus b to the 5th, 1, 5, 10, 10, 5, 1. A plus b to the 6th, 1, 6, 15, 20, 15, 6, 1. And you can keep going on and on and on, and you follow the idea. Now this allows you to find the coefficients to any polynomial of the form a plus b. All right? Now, let's get on to showing how to do definition of derivative. Okay. The first thing we're going to do, as with everything, I always write the expression or formula I'm going to use. So that's the limit as h goes to 0 of f of x plus h minus f of x all over h. It's the limit as the secant line goes to 0, as h in the secant line goes to 0. So that is the limit as h goes to 0, how do I find f of x plus h? Well, that means that everywhere there's an x, I put an h, x plus h, and then I add the 7 on, subtract on 5x plus 7, and put that all over h. Now I distribute, so that's the limit as h goes to 0 of 5x plus 5h plus 7 minus 5x minus 7 all over h. Cancel. Limit as h goes to 0, and I'm left with 5h over h. My h's cancel, so that gives me the limit as h goes to 0 of 5. The limit of 5 is 5, so f prime of x is 5. So notice that the limit of a line is simply the slope of that line. Okay, so now let's look at a quadratic. Again, the definition of derivative is g prime of x equals the limit as h goes to 0 of g of x plus h minus g of x all over h. To apply this, I find the limit as h goes to 0 of x plus h squared minus 3 times x plus h plus 5 minus parentheses x squared minus 3x plus 5 all over h. So g prime of x equals the limit as h goes to 0 of x squared plus 2xh plus h squared minus 3x minus 3h plus 5 minus x squared minus plus 3x minus 5 all over h. Cancel common terms. At this point, everything except terms with an h in it should go away. So if I have a term left that does not have an h in it, then I know I've made a mistake. So now I'm left with 2x plus h squared minus 3h all over h. So I'm going to factor out an h. The limit as h goes to 0 of h times 2x plus h minus 3 all over h. My h's cancel. So I have g prime of x equals the limit as h goes to 0 of 2x plus h minus 3. This h is going to go to 0, so I have g prime of x equals 2x minus 3. Notice that my derivative of a quadratic is a linear function. Okay? If you have any questions, please,